All right, welcome back. Today we'll be looking at 5.1 Part 3 or Day 3. All right, and man, it's unbelievable to me that a book thinks that you can learn all of that a student can learn all of this in 50 minutes. Blows my mind. I can barely explain it all in a complete fashion in 50 minutes. So, and let alone you guys understand it. So, 5.1 day 3 really requires that you know how to do day 1 and day 2 stuff well. So you need to be able to factor when a is equal to 1, the regular method where you think about what multiplies to give this and adds to give this. You also need to be able to factor using slide and divide, and you need to be able to factor out greatest common factors. Right? That's all a prerequisite. If you can't do that through the homework that I gave you and practice, you need to get to that point. Right? You need to get to that point. So what we're doing today requires you to do all of that and then an additional couple of steps. So today we're actually going to be we'll be solving equations. We're finally getting to the point where we can use this information to solve. So far, all we've been doing is taking expressions and changing the way they're presented to us. But now we'll be able to solve the actual equations. So that's basically the gist of it. So let's get to it. Now, these steps are like a cookie cutter set of steps that'll tell you how to do every type of solving polynomials. It's always like this. Get all your terms on one side so it's equal to 0. Factor using any method you'd like. Now that's the part that's so variable. And set each factor equal to 0 and solve each of those equations. That's the gist of it. So go ahead and write all of this down. Get all your terms on one side so it's equal to 0. Factor using any method. Then set each factor equal to 0 and solve each of those equations. Or solve. You can just write solve for that one. Hey, I actually use my mouse and you can tell it's not a very clean line. All right, so instead of my pen. All right, so let's try these methods or try these steps. So the first step was to get it equal to 0. Well, it's already equal to 0. I will give you a hypothetical problem that it's not equal to 0. So here's like, you might be thinking, well, what do you mean? It's always equal to 0, right? But no, it's not. So look at this situation. Right now, it's not equal to 0. And what you'd want to do is you would want to move all the terms on one side of the equation. But here's the catch. You want to keep the x squared term positive. Right now, the x squared term is positive, so you would not want to move it over here because you would make it negative, right? You don't want to do that. So you want to move the terms to whatever side of the equation would keep the x squared positive, right? That's important for the factoring. So that means you got to move all this stuff over here. And so add 18 to both sides, and you end up with exactly this. Okay, so this is a situation in which you could have a problem like this, and you would want to get it in this form before you continue. All right, make sure it's equal to 0. Anyway, that aside, let's go ahead and oh my God, come on now. All right, let's go ahead and start working this problem out. So the next thing we want to do after you've got it equal to 0 is factor using any method. Well, this is the easiest method to use. You think about what multiplies to give you this and adds to give you this. And the answer is -6 and -3. Those two numbers multiply to give you 18 and add to give you -9. So you've got x minus 6, x minus 3. And it's still, notice, that what we just did is the translation for this piece here. You still have this other stuff. You still have the equals 0 part. So you need to keep that. Now, the next step is I'll explain it at a fundamental level. The next step says set each factor equal to 0. Let me explain why you do that. All right, so give me just a second to cough. Yes, I still have a cough. So hopefully it's gone away by the time school starts, for God's sake. So here we've got two pieces of products. Okay, this is what's so important. I told you on that step up there to set each of these factors equal to 0 and to solve. So the idea was to set this factor equal to 0. So x minus 6 equal to 0. And this other factor equal to 0, x minus 3 equal to 0. If you just take it at, blind faith, which, I mean, I'd be happy that you do, but being inquisitive it's not a bad thing. So if you took that as gospel and you just do it, then that's fine. But I want to explain why. Why do we have this liberty? Why can we just set this equal to 0 willy-nilly? Well, I'll explain why. What we have done is, and again, another question you might be asking if you're inquisitive. Well, if we can set this equal to 0, each of this and this, why can't we just set this equal to 0, this equal to 0, and this equal to 0? I don't see the difference. Maybe if you're asking that, right? Well, let me explain why you can set these equal to 0 and it be true, but you cannot up here. All right, so I'll start here. So if you look, we have translated or rewritten our expression that was multiple terms. Multiple terms. You've got x squared, negative 9x, and 18. Remember, terms are separated by plus or minuses. And we have consolidated that into a single term, where you have x minus 6 multiplied by your x minus 3. And you might be saying, Mr. Dye, well, look, like, I see two terms right here. And yes, but think of this as a single piece of a product, hypothetically like some A quantity. It is being multiplied by some B quantity. This creates just like AB, which is just a single term. Just like 9x is a single term, AB is just a single term. Two pieces being multiplied. 9, or negative 9 in this case, obviously, is being multiplied by x. Just multiplication here. That's all that's happening here. You're taking this and multiplying it by this. Okay, so so we accept that. We're like, okay, well, we have written it now where it's something times something else. Big deal. I mean, why are you so up in arms about this? Why are you so passionate about this? Well, here's the catch. We know. This is the real catch. We know that when you multiply these two things together, it equals 0. That is powerful knowledge here. We know that when you multiply this times this, you get 0. That's important. So let's think about multiplication and 0. If I am saying that I have some quantity times some other quantity, and it equals 0, that gives us knowledge about one or both of these quantities, A or B. You try to think of numbers that multiply together to give you 0. Try. What can you multiply together to give you 0? Well, what if I had my first number be like 7? Is there some way to multiply 7 by some number to give me 0? Or negative 7? Maybe you've caught on at this point. The answer is, if one or both of these numbers are 0 as well, then when you multiply them together, you will always get 0. It's not that you'll get 0 some of the time or some conditional example, but you will always get 0. So if one of these values is 0, you will get 0. Okay, you might be thinking, okay, that's fine. I accept that. Definitely, if one of these values or both of these values are 0, then I will obviously get 0 when I multiply them together. Sure, then we're on the right track. Now let's think of another way. Is there any other way to take real numbers, multiply them together, and get 0 in a situation where neither of the numbers you're multiplying are 0 to start with? Basically, can you tell me two numbers that are not 0 that will multiply to give you 0? Or two numbers where one of them is not 0, right? Can you give me two non-zero numbers that multiply to give me 0? Think about that. The answer is no. This is what makes this so interesting, so important, is that the only way to get this equal to 0 by multiplying two numbers together is if one of them or both of them are 0. So that means you have to accept that either x minus 6 is 0 or x minus 3 is 0, or both of them are 0. And that is why we set this equal to 0 and solve, because either this piece here is 0 and or this piece here is 0. And so we set them up as equations. Now, this is also why, for any of you people who are inquisitive, this is also why the very first step says to get all of your terms on one side so you equal 0. If we had equaled like negative 18, hypothetically, then we would not be equal to 0 here. We would be equal to, like, hypothetically, or by this example, negative 18. And there are an infinite number of numbers that multiply to give you negative 18. There is not just one way to get negative 18 when you multiply, right? There's like 1 and 18, or negative 18, excuse me. Negative 1, positive 18, positive 1, negative 18. 2, negative 9. Negative 2, positive 9. 6 and negative 3, and negative 6 and positive 3. And that is just the whole numbers. Then you can start looking at like 36 and 1/2, where one of these is negative, and so on and so forth. There's an infinite number of possibilities that multiply to give you negative 18. So that's why we don't want us, like our equation, equal to a number. We want it, or a number that's not 0. We want it equal to 0 because 0 has this very important fact about it, where there's only one way to get 0 in a multiplication problem. All right, so that's, hopefully all of this has been like, wow, this is interesting. This makes sense. All right, this is powerful stuff. So all of this, our whole agenda here, our goal is to take advantage of this fact over here, that you need a piece to be 0 to multiply to get 0. We see that fact. We use that to our advantage to figure out what x can equal. All right, so back to the problem. Once you set these equal to 0, you just solve them. So you add 6 and you add 3, and you get x equals 6 and x equals 3. So x can equal 6 and x can equal 3. So those are your solutions, 6 and 3. Those are the values that make this true. If you plugged 6 in to both x's, you would get 0 times 3, which is 0, so that's true. And then if you plugged 3 in, you'd get negative 3 times 0, which is 0, so that's also true. So your answers are 6 and 3. Wow, great, awesome. This is another reason why I love doing these lessons online, is that I can give these detailed, complete, to my knowledge, complete explanations of this content, and you can re-listen to it and see until it makes sense to you. Or if you're the type of student who you just don't like this sort of stuff, then you can skip it, and I'm not getting interrupted by students asking me questions halfway through and that kind of thing. So let's move on to the next problem. Now we'll go step by step. Get equal to 0. So this 11 has got to move. So you're going to subtract 11 from both sides. All right, so far so good. You get 6x squared plus x minus 15 equals 0. So now you have to factor. And the way you factor this is by slide and divide. That's what you have to do, because you don't have 1x squared, you have 6x squared. So you have to slide and divide in this example. All right, so slide and divide. Like I said at the beginning, hopefully you know how to do slide and divide. I'm just going to go ahead and burn through those steps. Slide 6 over. X squared plus x minus whatever, 30, 90? Actually, while I'm sliding and dividing, I'm not going to put equal 0. So now you factor. Oh, man. 3 and 30, 4, 5, 6, 15. Let me get a calculator out. All right, give me a second. All right, so getting a calculator out, let's go ahead and look through the factors of 90. So this is my method to use to see what two numbers multiply to give you positive or negative 90 and add to give you 1. They're numbers that are 1 apart from each other. I just can't think of them off the top of my head. So divide by 2, you get 2 and 45. Those are not going to add or subtract to be 1. So then you take 90 divided by 3, and 3 and 30 are not going to do it. Divide by 4. That's not even coming out as a whole number. Divide by 5. 5 and 18, you're getting closer, but not there yet. Divide by 6. 6 and 15, you're getting closer still. Divide by 7, I don't think, 7 doesn't go into it. 8. 8 doesn't go into it either. I don't know why I'm doing this. 90 divided by 9. Hey, wow. See, my brain should have thought of that. 9 and 10, that's correct. So one of them positive, one of them negative to make a positive 1. So make the 10 positive and the 9 negative. So you've got x plus 10 and x minus 9. And now you divide by the number you slid. So divide by 6, reduce your fractions, x plus 5 over 3 and x minus 3 over 2. Then move your denominators, 3x plus 5, 2x minus 3, and that equals 0. So all right, so we factored using slide and divide. Now you set each factor. You set each factor equal to 0 and solve. So set 3x plus 5 equal to 0 and 2x minus 3 equal to 0 and solve. So you would subtract 5, and I'm going to treat you like you know how to solve a two-step equation. Add 3, and you get 3x equals negative 5 and 2x equals 3. And then divide by 3 and divide by 2. And you get x is equal to negative 5 thirds and x is equal to 3 halves. And that's it. Those are your answers. All right. Let's do this problem here next. So this is a case in which you need to factor out it's already equal to 0, so we're in good condition there. But there is definitely common factors among these values here. That's what you want to do. You want to look for greatest common factors. So what's the largest number that goes into 10 and 25? Both of them. Well, that would be 5. And then how many x's can you afford to divide away or take away? Well, you had 2 here and you have 1 here. So you can afford to take away this 1 and take away this 1, or 1, and then this will cancel, giving you just x to the first power. So you can afford to take away a single x because you only have a single x here. And you have x squared here. All right, so you can factor out 5x. And so when you factor out 5x, remember that's like dividing by 5x. So you would get 10 over 5, which is 2, and then x squared over x, you subtract the exponents, so it would be 2 and 1, you're taking away 1, so it'd be x to the first, minus, and then 25, because it's minus because it's negative, and then 25 over 5 is 5, and then x over x cancels, and that equals 0. Now, when you arrive at a situation like this, it's pretty unfamiliar to us. We've not done a problem like this. Give me just a second. We've not done a problem like this. But remember back to this explanation I was talking about right here, where when it's equal to 0 and you have two things multiplying by each other or more, that they have to equal, like, the only way to make a product equal to 0 is if one or more pieces of the product also equal 0. So we can use that information here as well. We still have a product going on here. We've got 5x being multiplied by the 2x minus 5. So that means you can set 5x equal to 0, and you can set 2x minus 5 equal to 0. This will come up a lot. And this relies on that information we learned earlier. So now you just solve each of these. Set each of these equal to 0 as we're supposed to, and now solve. So you divide by 5 here, divide by 5. 0 divided by 5 is 0. So you get 0. And then here, add 5, you get 2x equals 5, and then divide by 2, and you get x equals 5 halves. And those are your solutions. All right? Last example, and we'll be done. This is like what you'd expect to see on a test, something like this. Well, I mean, I haven't worked it out recently, but I'm assuming it works out okay. So this is a situation where you got to move multiple terms. So you got a minus 12 to get the 12 over, and then add 4x and add 4x to get the 4x over. And that's the first step. Get it equal to 0. So you get 12x squared plus 17x minus 5 equals 0. Now you factor using any method, and the method we have to use is slide and divide. That's all we know how to do because this is 12 and not 1. You have to use slide and divide. So slide and divide, you get x squared plus 17x minus 60 equals 0. So go through the factors of 60 that could, or negative 60 that could add to give you 17. So 60 divided by, well, I think 5 and 12 do it. Yeah. Well, no. They would, but you have a negative 60. So one of these values has to be negative, so that can't work. So what about 60 divided by, I don't know, 4? No, 60 divided by 3? Hey, that works. 3 and 20 make the 3 negative and the 20 positive. So x plus 20 and x minus 3. Those multiply to give you negative 60 and add to give you positive 17. And then you divide, so you slide, and now you divide by the number you slid, which was 12. And now you reduce. So that would be 10 over 6, which would be, oh, excuse me. Okay, it'd be 10 over 6 when you divide by 2, and then you divide by 2 again, it'd be 5 over 3. And then you've got dividing by 3, so it'd be 1 over 4. And now you move denominators in front of x's, and you get 3x plus 5 and 4x minus 1. That's done. You're done factoring. And now you set each factor equal to 0 and solve. So you get 3x plus 5 equals 0 and 4x minus 1 equals 0. And you get to solve each of these. Minus 5 plus 1, and you get 3x equals negative 5 and 4x equals 1. And then you divide by 3, divide by 3, divide by 4, divide by 4, and you get x is equal to negative 5/3 and x is equal to 1/4. And you're done. Congratulations, you're done with this lesson. Hopefully it's been okay. Work on your homework. If you have any questions, ask me about it, as always. We are finally done with the first section, and if I'm going to stay on pace and do a chapter a day, oh my good God, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 more lessons to record today. Okay, well, you do your homework, I'll get to recording. How about that?